Hey y'all, we're going to do writing those ionic formulas now. So we practiced naming them and now we're going to write some. So this is what I was talking about earlier, this like crisscross method of writing ionic compounds, and I think that it works sometimes, but it doesn't work all the time. For example, this formula is wrong, and I've got this from your textbook, so you gotta watch out for this. So you have to write ionic compounds in lowest whole number ratio. So is a 2 to 2 a lowest whole number ratio? No. So how can I write this correctly? I would have to write MgO. So I'd have to reduce it if I wanted to do this crisscross method, which is take the charge of your cation and make it the subscript of your anion, and take the charge of your anion and make it the subscript of your cation. And then make sure you reduce it to lowest whole number ratio. So that's kind of the shortcut way of doing this. I'm going to show you the mathematical way of doing this, which is very similar to what we talked about with the type 2 writing of the names of these compounds. But ideally, you need to have your total positive and total negative charge be equal to each other. And what's happening in here is that it takes 2 chlorines essentially to satisfy 1 magnesium, because magnesium's goal is to get rid of these 2 electrons, and chlorine's goal is to take 1. So 1 chlorine is not going to satisfy magnesium because magnesium is trying to get rid of 1, but magnesium is trying to get rid of 2, but chlorine's only going to take 1. So what we have to do is put 2 chlorines in. So magnesium is going to give away 1 to this chlorine and 1 to this chlorine. Therefore, it takes 2 chlorides to satisfy 1 magnesium ion. So I get this kind of math here. So this is the math that I will do, I have already showed you in the previous video, but we will kind of use this as our way to figure out, make sure that our charges are adding up to 0. So now what we're looking for is how many of each does it take. So now my kind of goal is to find these numbers, not so much to find the charge. So the same thing happens here. Sulfur is trying to gain 2, and sodium is trying to get rid of 1. So sodium can give 1, but the sulfur is like, well, I'm trying to get 2. So you need 2 sodiums to satisfy a sulfur. So we get sodium sulfide is Na2S. And again, my goal is to try to find these numbers that go with your subscripts to tell you how many of each. So we can practice, and you may kind of see some practice sometimes in this little chart, which means that we're going to put the positive with this negative, then I'm going to put this positive cation with this negative anion, and then I'm going to put this positive with this negative. And in the middle here, I'm going to write the formula and the name of all of these. Remember that your positives always come first. Cations come before anions, and so we're going to write the positives first in the formula and in the name. So see if you can figure out how to put these together to get neutral compounds, and then try to give them some names. All right, so hopefully you have given this a shot. Let's see what we got here. So I like to write everything out. You know me, I'm trying to label everything, I'm trying to write everything, and so I'm going to say the sodium ion and the bromine ion. This is a 1 and this is a 1. And so it's super easy to write them if they have the same charge. If they've got the same charge, you just need 1 of each, 1 positive and 1 negative. That's going to give you your formula. So I need 1 sodium and 1 bromide, and I'm going to call it sodium bromide. Because sodium is a type 1 metal, it doesn't need Roman numerals or anything. So moving across to the right, I have sodium, and notice that I like to write the ions next to each other with the charge, so that either if you want to do the crisscross you can, or if you want to try to do the math. I'll show you the math for this one since it's a little bit harder. So I know the sodium is +1, but I don't know how many I need. And I know the sulfide is -2, but I don't know how many I need, and I know it's got to add up to 0. So I'm trying to ask myself, what goes in these blanks? Like, how many +1s and how many -2s do I need to add up to 0? So think about adding more of your smaller ones to get to the bigger one. So the bigger one here, or bigger absolute value, is the sulfide. So how many of these sodium ions do I need to cancel out a sulfide? I need 2, right? I need 2 positive ones to cancel out a negative 2. So knowing that, when I make my formula, I will have 2 sodiums and I will have 1 sulfide, so Na2S. And so the name is sodium sulfide. And we dropped the UR, I don't know why, like it's not sulfuride, it's just sulfide. But then in other ways we use sulfur, we don't drop the UR. It's weird. Someone decided that something sounded better one time and then they wrote it down and people were like, oh yeah, that's great, let's just use it. I don't know. It makes no sense sometimes. A lot of things in the English language don't make sense. So sodium and then this nitrogen ion. So same thing, I'll do a little bit of the math for you. So how many plus 1s plus how many minus 3s? And again, if you want to do the crisscross, go for it. Just remember that if you crisscross, you also have to reduce. So I need 3 positive 1s to balance out 1 negative 3. So that means that I need 3 sodiums. And I will call this sodium nitride, because nitrogen will turn into nitride. So now it's gonna get a little harder. We're gonna use aluminum, which has a positive 3 charge, so not as quite as easy as a positive 1. So aluminum has a positive 3, bromine has a minus 1. And this one's a little easy. I need, if you could do the math if you want to for this one, but you need 3 negative 1s to balance out a positive 3. So you don't have to write that math out for these. There's no work you have to show. Sometimes you can just kind of do it in your head, or if you're crisscrossing, you can go for it. AlBr3, and this would be called aluminum bromide. I have aluminum and I have sulfide. Now this one I will do the math out because it's a little bit harder to see. So I'm trying to get 3 and 2 to cancel each other out. They must equal 6 because that's the least common multiple. So how do I get 6 from 3? I got to multiply it by 2. And how do I get 6 from 2? I got to multiply it by 3. So if you ever have, it's not obvious, look for a least common multiple. If they're both the same absolute value, they will cancel out if one is positive and one is negative. So I need 2 aluminums and 1 sulfide to balance out. 2 aluminums and 1 sulfide to balance out. So I call this aluminum sulfide. And then my last one is also an easy one. They're both the same charge, absolute value-wise, so I just need 1 of each, AlN, 1 of each. Now if you crisscross this, you get Al3N3. You can't leave it like that because it's not the lowest whole number ratio, so we have to make sure that you balance it, reduce it down. Aluminum nitride. Hopefully those made sense. If not, text me right now and ask for some help. We're going to do some more practice here. So tell me what the chemical formula is for these 3. So looking at this one, the first thing that I want you to do, I do not want you to just write the formula. We're not there yet. I'm just learning how to do this for most of you. I want you to write the charges out. Nickel has a charge. What's the charge of nickel? It's +2. How do you know that? I'm telling you the charge of nickel right here. Remember, the Roman numerals tell me the charge. So the charge of nickel is +2. It's not one charge that you have to memorize. Then your sulfide is 2-. Now you should know that because of where it is in the periodic table. Now if I have these and I'm actually looking at the charges next to each other, it's very clear that this is going to be NiS, right? Because it's a 2-to-2 ratio, which is a 1-to-1 ratio. And if I crisscrossed it, I will have to reduce it back down. Okay, and so the next one, what is the charge of zinc? Well, zinc does not have Roman numerals, but it's in the middle of the periodic table. But it's one you should know. So it's a type 1. It's always +2. And then chloride you should know is -1. So how can I put these together? ZnCl2. 2 negative 1s balance out 1 positive 2. Then I have my iron 3 oxide. Again, that 3 tells me the charge. And oxide is -2. Do my math out, I get Fe2O3. Hopefully that made sense. What about those polyatomic ions you were memorizing? So what happens if you have to deal with some of those? Well, we're going to treat them just like we treat any other ion, except we do not change the ending to their name. So you know how I changed the name of oxygen to oxide? I'm not going to touch these. Once you memorize a poly, you do not touch its name. You do not touch any of the numbers in it. We only combine it, add it to stuff, or we put parentheses around it maybe, but we do not ever touch anything inside of it, and we do not change the name of it at all. So if I wanted to look at the names of these, if I put calcium with the sulfate ion, what do you think I would call this? This CaSO4. What would I call this? I would call it calcium sulfate. That's it. Don't change. It's not sulfide, because sulfide is different. Sulfide is just S2-. This is sulfate. It's got oxygen in it. So we want to make sure that we're not changing that. Notice that it's 1 calcium and 1 sulfate because it's a +2 and -2. So my ratios are still going to work out. I'm still going to get that that balanced chemical formula where we're all neutralized. Okay, notice here I have ammonium has a plus charge and nitrate has a -1 charge, so I need 1 of each, so that's why there's 1 of each. There are not 4 ammonium ions here. There are not 3 nitrates. There's 1 ammonium and there's 1 nitrate, giving you 1 ammonium and 1 nitrate. You have to learn these, you have to memorize them so that you don't think the 4 goes for something else. The 4 is part of the ammonium. So I just will call this ammonium nitrate. We're not changing anything about the names. Look at ammonium nitrate though, it's kind of special. Are there any metals here? No, but it's ionic because NH4+ is an ion. So you have to be careful because anything with ammonium, it's going to look like it's covalent because it doesn't have any metals. It's not going to look ionic when you first look at it. But if it's got NH4 and then something else, it's ionic because it's got ammonium, and ammonium is an ion. So here are some of those polyatomic ions you're memorizing. I just want you to look at something. Let's look at the chlorine series here, okay? And this is going to be very similar to bromine and iodine. Fluorine doesn't really do it too much, but like if you wanted to look at bromine, it would be BrO4- is per bromate. So if you know the chlorines, you know the bromines and the iodines. Iodate for IO3, and it's all got the same charge. So if you look at the elements, you can see that they all have very similar charges for this series. So the series is chlorate, perchlorate, chlorite, and hypochlorite. So let's think about what some of these parts of the words mean. First, your 8 is greater than your 8. 8 doesn't always mean 3 or 4. 8 just means more than 8, meaning it has more oxygen than 8. Then what comes above your 8? What has more oxygen than 8? Per 8, like hyperthermia means too much heat, or hyperactive means too much active. So per 8 is more than 8. What is under 8? Hypo 8, like hypothermia, meaning not enough heat, or hypothyroidism, meaning your thyroid is less active. So hypo 8. So if you can just memorize the 8, all you have to do to make the per 8 or the 8 or the hypo 8 is to change the number of oxygens, because the charge stays the same in all of them. The only difference between them in a series is the number of oxygens. So if you just memorize all your 8s, you know all the rest of them. If nitrate is NO3 minus, nitrite is NO2 minus. Same charge, different oxygens. And then the other thing to kind of notice is that if I add in a hydrogen, it changes the charge. So hydrogen sulfate is like hydrogen ion plus sulfate ion makes HSO4 minus 1 because you're adding a plus. So it's like adding a hydrogen ion to it. So if you want to remember that, it can be helpful. If you just want to straight up memorize all of them with flashcards, go for it. But you do need to know these. It will help you talk to patients about things. Nitrates are medications for like chest pain. You've got nitrates and nitrogen compounds and phosphorus compounds in different gardening chemicals. Hypochlorite is sodium hypochlorite is the main ingredient in bleach. So just like you will be more educated about the chemicals in the world around you and the chemicals that your patients will come into contact with or maybe accidentally ingest. And so it's just good to kind of have these names memorized because when you see them, you kind of get an idea of at least what it is, that it's a chemical compound. And not necessarily needing to like tell your patient, oh, that's PO43 minus, but like just knowing that, oh, that's part of an ionic compound. And then if you know it's an ionic compound, you can know certain things about it, like if it's going to dissolve in water or not. Like these things might be crucial to giving detailed care to someone or helping just answer your family's questions about something that they want. Like if you work in the medical field, that as soon as you work in the medical field, your family is coming out the woodwork asking you to look at this or ask questions about this. I'm not even in the medical field, but because my husband and I are scientists, our families are always like, what about this thing I have on my foot? We're not doctors. So but they do ask us about like, oh, I saw this chemical, this medication had something, like what does that mean? And I don't want to sound like, I will tell them all the time, like, I do not know, but you should ask your doctor. So that means I'm sending them to y'all. They're going to come ask you what all this stuff means. So you should have some kind of idea of it. So, keep this list up, but you also should have your memory list, flashcards kind of working through these. So again, here's everything I was just talking about with the 8s and the ites kind of laid out in the slides for you to look at. Exceptions to the rules, you've got a couple of "-ide" ones to know: cyanide, hydroxide, and peroxide. Per just means more oxygen, so peroxide literally means more oxygen. Here's how we make those hydrogens or bicarbonates. And then here's your chlorate series again. They kind of just throw it out there for you. And here's how we name some stuff. Notice that we just kind of name it like we name normal ionic compounds, except you don't change anything to IDE. We just you memorized all those polyatomics. You do not change anything about them when you're writing the names. So let's try it. Let's write the formulas for these. Okay, so with any formulas or any names, it's really helpful to write the ions out. So if you're trying to go straight to the answer, you might get it wrong. I would strongly suggest that unless you have had a lot of practice with this, that every time you're given something that we write the ion out. So write aluminum ion and then write that nitrate out, exactly as you memorized it. Now, how many nitrates is it going to take to balance out an aluminum? So let's think about it. How many plus 3s and how many negative 1s? This 3 is part of nitrate, so it's one whole thing with a negative charge. So it's, just like a chloride as far as the math goes. Well, I know I need 3 negative 1s to balance out 1 aluminum. So how can I write 3 nitrates? If you need more than one of these, you must use parentheses. Okay, polyatomic ions. If you need more than one of these, you must use parentheses. So we use parentheses when we need more than one polyatomic ion. When more than one poly is needed. But we don't use parentheses when we just need one. That's not the rhyme. When you need more than one of these, you must use parentheses. So that's my aluminum nitrate right there. Okay, let's look at copper 2 nitrate. What's the charge of copper? 2. How do I know? It is the Roman numeral. I have to tell you because it's not one of the ones you always got to know. It's not a type 1. And nitrate is the same as before. How many nitrates do I need this time? I just need 2, right? So let's do copper, 1 copper, 2 nitrates. So you can see how this can become less work. But I think that even more important than writing the math out is just writing the ions. Because if I can write these ions out and see what's going on with them, then it's easier for me to kind of just skip to the end, right? I don't really have to do the math out if I can say, oh, I need 2 -1s to balance out a +2. And so kind of take it out of the words and put it into the chemical symbols before you do this part, and I guarantee you will get them right more often than if you try to go fast and just write them down. And definitely do not Google these, because you will find that Google is going to give you some common names or common formulas, and I'm asking you for the very specific type of chemical formulas called IUPAC, which is the International Union of Physical and Applied Chemistry. They have decided on a specific naming formula, naming functions, and then there's a whole other list of common names. So like you read common names if you read the back of your shampoo bottle. Okay, there's a lot of common names and weird names in that. But we're using the specific formal naming system. So sometimes if you Google, you will get the common name. And I know we didn't talk about the common names because it's impossible to memorize all of them. So you're giving me a flag that you're Googling if you are writing that down. So be sure to just try it this way. Google to check if you want, but if you see something different, very different, then check it with me before you trust it, because it may be wrong for what you're trying to do right now. Trust yourself and trust me, and don't always trust the Google. So iron has a charge of what? Iron has a charge of 3, and hydroxide is OH minus. So here's where you got to use parentheses here, because if you don't use parentheses, it will be wrong. If I try to say, oh, that's 3 OHs, is that 3 OHs? It's not 3 OHs. It's 3 H's and 1 O. If I want 3 OHs, I have to put parentheses around it. And let's look at 10. What does this Roman numeral stand for? 4. 10, 4. Hydroxide. And again, I will need parentheses around my hydroxide. You gotta put parentheses if you have more than one poly. Here's how we deal with some of those polys. All right, if that didn't make any sense, you need to text me. Let's name it. Try the other way around. So again, even when you're naming it, I think it's so helpful to just try to write the ions out. When I see that's calcium, oh, I'm writing the wrong thing. See, I get myself mixed up if I don't write it out. And then that's nitrate. How do I name that? Oh, it's calcium and it's nitrate. Calcium nitrate. And I don't really have to write the ions out, but it's just good habit to like try it to see what I got here. Now I do probably need to write them out here. Iron and phosphate. And I don't know the charge of iron. Iron needs Roman numerals because it's what type of metal? It's a type 2 metal, so it has 2 or more types of charge. So you have to tell me what the charge of iron is, because you can't just say iron phosphate. I don't know what iron you're talking about. And we remember that when we're talking about the differences of tiny little differences make big changes in the way the chemicals behave. So iron 2 phosphate and iron 3 phosphate, they're different things. You got to tell me which one you're using, because I won't know the difference. So how can I figure this out? Well, I have 1 iron that I don't know what it is. How many phosphates do I have in the formula? Just 1. There are not 4 phosphates. What does 4 phosphates look like? This is 4 phosphates. That's not what I have here. I have 1 phosphate. Remember, we don't put parentheses around polyatomics if we only have 1. So if you see a polyatomic ion without parentheses, it means there's just 1 of them. One thing I do know is -3 has to equal 0. So my iron has to be +3. So that's iron 3 phosphate. I know, it's a lot. You will do so much practice with this. You're going to be perfect experts by the time we're done.